Before this, Harris drilled us on circuits that lied phantom voltages, short circuits, and sparks that shouted louder than words. We ended with the rule etched into our voices: test before touch. Circuits had shown their deceptions, and breakers had proved they could not always be trusted. Now the lesson shifted. Harris said if electricity flowed like blood, then wires were its veins. And if we chose the wrong veins, the whole body of the building would suffer. The workshop smelled different today, sharper, metallic, like copper shavings and insulation. On the bench lay coils of wire, some copper, some aluminum, some thick and heavy, others thin as thread. Beside them sat conduits, clamps, spools, rolls of tape, and boxes of wire nuts. Harris stood behind it all, arms folded. His voice was steady and cold. Electricity is invisible. Yesterday, you learned that circuits lie. Today, you meet the veins of power themselves. Wires. They carry life. They also carry death. Respect them, or they will betray you. Maria poked at a roll of aluminum wire. It just looks like string. Harris's eyes narrowed. That string can kill you faster than a knife. What is the difference between copper and aluminum? I raised my hand. Copper conducts better. Less resistance. Correct? And aluminum. Maria frowned. Cheaper, yes, and weaker. Aluminum expands when hot, loosens connections, and burns buildings. Code allows it, but only with special fittings. What happens when you ignore that? Loose connections, I said. And loose connections cause? Heat. And heat causes. Maria sighed. Fire. Correct. Older John narrating. Years later, I saw an apartment fire start at a single aluminum splice. The landlord had saved money on copper. The wires loosened after a year. Flames took the entire second floor. The price of cheap was millions. Harris grabbed a roll of copper. What is a WG? American wire gauge, I said. And what does gauge mean? Thickness, Maria answered. And what happens when gauge number is smaller? Wire is thicker, and thicker wire carries more current, I said. Correct. 14 gauge, 15 amps, 12 gauge, 20 amps. Out. 10 gauge, 30 amps. Know these numbers or someone dies. Maria groaned. So math again. Yes. Math saves lives, Harris said. He handed me a wire stripper. John stripped this 12 gauge. I clamped too tight. The copper nicked. Harris snatched it away. What mistake? I damaged the conductor. And what does that cause? Weak point. Heat. Failure. Correct. Respect the copper. One careless cut is a future fire. Maria tried next. She stripped too shallow, insulation still clinging. She yanked it free, tearing strands. Sparks flew in Harris's eyes. What mistake? Strands cut, Maria muttered. And what happens to a stranded conductor with half its strands gone? Less current capacity, I said. And what happens then? Overheating? Overheating causes? Maria threw up her hands. Fire. Okay, fire again. Correct, Harris said. Older John narrating. I once saw a stranded cable feeding a rooftop unit. The apprentice had nicked half the strands. For months, it ran hot until it burned through. The unit shut down in the middle of a summer heat wave. A hospital lost cooling. Patients suffered, all from one careless cut. Harris pointed at a bundle of wires. What does insulation do? Protects from contact, I said. What materials are common? PVC, rubber, thermoplastic. And what happens when insulation cracks? Shock, arc, fire. Maria muttered. You don't even have to ask anymore. Then say it louder, Harris snapped. Shock, arc, fire, she shouted. Good, remember it. We practice pulling wires through conduit. Harris barked orders. John, what do you put on wires before pulling? Lubricant if needed. And why? To reduce friction. And friction causes, heat and heat causes, fire, I said. Maria groaned. I swear you enjoy this. Fire enjoys you more, Harris said. We cut wires, bent them, connected them into a junction box. Harris inspected every move. What happens if you overload a wire? Insulation melts, I said. What if breaker is too large? Wire burns before breaker trips. And what if wire is too small for the load? Voltage drop, Maria said. And voltage drop causes Dim lights, overheating motors, failure. Correct. Code is numbers, not feelings. Respect the chart. Older John, narrating. I once worked in a shop where machines kept shutting down. The contractor had used 14-gauge wire on a 20-amp circuit. The breaker never tripped. The wires smoked in the ceiling. By the time they found it, the insulation had already turned black. The air felt hotter. The copper in my hand seemed heavier. Maria blew a strand of hair out of her face. So wires are liars too? No, Harris said. Wires never lie. They do exactly what physics demands. You are the liar when you choose wrong. We ended by labeling each conductor. Harris quizzed us again. What color is neutral? White. What color is ground? Green or bare? What colors for hot? Black, red, sometimes blue. And what happens when you reverse neutral and hot? Shock hazard. And what happens when ground carries current? Unsafe fire risk. Correct. Remember, color is language. Wires speak. If you misread, you kill. Harris shut the panel hard. The sound echoed. Lesson 1. Copper is life. Lesson 2. Aluminum is danger. Lesson 3. Gauge is law. Learn the veins of power, or power will cut your veins. Tomorrow, we learn conduits and clamps. And metal has no mercy. Maria whispered, I hate tomorrow already. I closed my notebook, my fingers trembling. The copper coils on the bench looked like snakes waiting to strike. Coming up next, Episode 11, Conduits, Clamps, and the Price of Carelessness. Previously, Harris led us through the veins of power wires themselves. Copper against aluminum, gauge numbers that meant life or death, insulation that could either protect or betray. We learned that breakers protect wires, not machines, and that every splice or strand tells a story. By the end, Harris's words rang in my ears. Gauge is law. Code is survival. Now he placed metal pipes on the bench, warning us that wires cannot protect themselves. Today was about conduits, clamps, and the mistakes that slice insulation before a current even flows. The workshop smelled of machine oil and dust that morning. On the long bench lay rows of conduits, EMT, PVC, and rigid steel. Beside them sat hacksaws, remmers, conduit benders, and boxes of clamps and fittings. The tools gleamed under the harsh fluorescent lights. Harris stood behind it all, his arms crossed like a sentinel. Yesterday, you met wires, the veins of power. Today, you meet the bones that protect them. Conduits. Without them, wires die young. Without clamps, conduits betray you. Respect them. Or the building you wire will betray everyone inside. Maria picked up a piece of PVC, turning it in her hands. It's just plastic pipe. What's the big deal? Harris's voice cut the air. What happens when you run PVC outdoors in sunlight? It melts. I guessed. Not melt. It degrades. UV eats it. It cracks. Water leaks in. Wires corrode. Ground faults spread. One crack can shut down a factory. What does EMT do better than PVC? It protects from impact, I said. Correct. Steel resists blows. But steel rusts. And rigid steel. Stronger still, but harder to work. Heavier. More expensive. Choose wrong, and you fail before you begin. Maria sighed. So even pipes are dangerous now. Not dangerous, Harris said. Unforgiving. He lifted a hacksaw and dropped it onto the table with a clang. John, cut this piece of EMT. I clamped it, sawed awkwardly. The blade squealed. Metal shavings scattered. When I finished, the edge was sharp and jagged. What mistake? Harris asked. I swallowed. Didn't ream it. And what happens if you don't ream? The sharp edge cuts insulation. And what happens when insulation is cut? Short-circuit fire, Maria muttered. Of course. Fire again. Correct, Harris said flatly. Say it louder. Short-circuit fire. Shouted. Good. Respect the edge. Always ream. Older John, narrating. Years later, I found a warehouse where lights flickered randomly. The crew thought it was bad ballasts. The truth. Wires were shredded on the sharp edge of an unreamed conduit. Sparks had been jumping inside the pipe for months. When the fire inspector saw it, he said one word, careless. Harris handed the remmer to Maria. Fix it. She scraped the edge, rolling her eyes. Whoa, this tiny step saves lives. Yes, safety hides in small steps. Forget them, and your mistake grows into fire. We practiced with connectors and fittings. Harris quizzed as we worked. What tool tightens conduit fittings? Channel locks, I said. And what happens if fitting is loose? Wire rubs, arc fault, fire. And what if fitting is over-tightened? Conduit crushed, wires pinched. Maria groaned. So either way it's wrong, Balance Harris said coldly. Tight enough to hold, loose enough to breathe. He set up a run of conduit and clamps. Maria installed these. She rushed, snapping clamps carelessly, some too far apart, others crooked. What mistake? Harris asked. Maria frowned. They're on. Wrong. What is the maximum spacing for EMT clamps? 10 feet? I guessed. 10 feet for horizontal? 3 feet within a box? Learn the code. Spacing keeps conduit from sagging, wires from pulling, fittings from failing. What does sagging cause? Stress on wires, I said. And stress causes heat. Fire. Correct. Older John, narrating. I once saw a conduit sag across a factory ceiling. Over years, the weight pulled wires until insulation tore. One morning, a motor shorted. Flames spread across rafters. All because no one bothered to set enough clamps. We bent conduit next. Harris showed us the bender. What angle is this? He asked. 30 degrees, I said. And how many degrees in an offset? 2 bends, usually 30 and 30. And what's the rule for total bends in a run? Not more than 360 degrees? Correct. Why? Too much friction? Wires won't pull. What happens when wires are forced? Insulation tears. Maria muttered. And fire. Yes, we know. Yes, Harris said calmly. Because you always forget, we've bent off sets, saddles, and 90-degree elbows. My arms ached from pressing the bender. Maria complained about the weight. Harris barked corrections nonstop. What happens if bend is too sharp? Wire kinks harder to pull. What tool measures radius? Protractor? What's the best practice after bending? Check alignment with level. And what if it's crooked? Stress on fittings. Failure. Maria wiped sweat from her brow. So the pipe doesn't forgive crooked either. Nothing forgives crooked, Harris said. Straight is safe, crooked is careless. Older John, narrating. Once I saw a hospital job where conduits snaked crooked across the ceiling. The inspector failed it. The contractor rushed, tried to fix by forcing wires through. Weeks later, a nurse reported smoke in the ceiling. Crooked had become fire. We spent the rest of the day cutting, reaming, bending, clamping. Harris quizzed us endlessly, drilling numbers and code until they burned in my head. What is minimum burial depth for PVC outdoors? 18 inches? What's required when conduit enters a box? Connector with lock nut and bushing. And why bushing? To protect wires from sharp edges. What's the rule for conduit fill? No more than 40% of cross-sectional area? Maria groaned. This is worse than math class. Math class doesn't kill you, Harris said. By the end, our runs of conduit gleamed in the harsh light, neatly bent, clamped, and aligned. Harris inspected silently, then finally nodded. Lesson 1, conduit is armor. Lesson 2, clamps are guardians. Lesson 3, edges are knives. Forget any, and you kill. Tomorrow, we learn code capacity and the lesson written in burnt insulation. Maria sat on a spool of wire, her hair damp with sweat. I swear, even pipes want to burn me alive. Not pipes, Harris said. Your mistakes? I closed my notebook. My hands ached from bending steel, but the numbers in my head ached more. Next episode, code, capacity, and the burnt lesson. The last session ended with steel and clamps in our hands. Harris drilled us on conduits, cutting, reaming, bending. Spacing reminding us that even a crooked pipe could turn into fire if we ignored the rules. Maria complained that everything ended in the same word, but Harris's voice cut through. Conduit is armor, clamps are guardians, edges are knives. Forget any, and you kill. Now the tables had changed. Charts, codebooks, and blackened wires waited. Today was not about bending metal, but about learning the hidden numbers that decide whether circuits live or burn. The workshop smelled of sweat and steel. But today the tables were stacked with charts, code books, and burned pieces of wire mounted on a board. Some were blackened and brittle, others melted into twisted lumps. Harris stood in front of them like a judge displaying evidence. Today, he said, you learn capacity. Wires have limits. Ignore them, and the result is always the same. Yes. He pointed to the melted copper. This is the language of failure. You will learn to read it before you create it. Maria wrinkled her nose. It smells awful. That is insulation turned to poison, Harris said. Burned plastic fills lungs. A man can survive fire, cannot survive what the smoke writes inside him. Now, questions? Cracked the board with his knuckle. 14-gauge copper. What is its capacity? 15 amps, I answered. Correct. 12-gauge. 20 amps. 10-gauge. 30 amps. Maria rolled her eyes. Do we have to memorize the whole chart? Yes, Harris snapped, because if you don't, you kill. What happens when you put 14-gauge on a 20 MP breaker? Wire overheats before breaker trips, I said. Maria muttered. Of course. Correct, Harris said. Older John, narrating. Years later, I walked into an office fire investigation. The breaker sat intact, never tripped. The wires above the ceiling tiles had melted into tar, were too small for the breaker. The company lost everything in a single afternoon. Numbers are not math. Numbers are law. Harris held up a chart. What does conduit fill? The percentage of space wires can occupy, I said. And what is the maximum? 40%, I answered. Correct. And why not more? Too tight. Heat builds, wires rub, insulation fails. Maria sighed. And fire. Yes, Harris said coldly. He handed Maria a roll of aluminum wire. What happens when aluminum expands and contracts? Connections loosen, she muttered. And what do loose connections cause? Heat. And what does heat cause? Fire. Fine. Fire. Correct, Harris said. We practice pulling wires through conduit. Harris barked numbers. John. Maximum number of current-carrying conductors before derating. More than 3. And what is derating? Reducing ampacity. And why? Heat buildup. And what happens when you forget? Insulation melts. Fire. Maria groaned loudly. It's always the same ending. Because you always forget, Harris said. He pointed at the panel. What does breaker size protect? The wire, I said. Not the load. The wire. Never forget. People think breakers protect equipment. Wrong. Breakers protect conductors. The wire is what fails first. Remember that, and you will save lives. Older John, narrating. I saw a mechanic replace a breaker with a bigger one because his machine kept tripping. The machine ran fine for a month. Then one morning, the wires behind the panel burst into flame. He had protected the machine, not the wire. The shop closed forever. Harris handed me a burned piece of NM cable. The sheath was blackened, the copper exposed. What happened here? Overloaded circuit, I said. And how can you tell? Insulation melted, copper oxidized, correct? And what does the color of copper tell you? I frowned. Bright means new, dark means overheated. Yes, copper speaks. Listen to it. He handed Maria a wire nut, blackened and cracked. What happened here? She squinted. Loose splice. Correct. Loose means resistance. Resistance means heat. Heat means fire. Every splice tells a story. We spent hours with charts, matching breaker sizes to wire gauges, calculating loads, balancing panels. Sweat dripped down my back as Harris barked more numbers. What is the formula for power? P equals V times I. What happens when current doubles? Power doubles. What happens when wire size stays the same? Overheating. And when breaker doesn't trip? Fire. Maria muttered. I could have answered that before class. Then say it louder, Harris demanded. Fire, she shouted. Good. At least you learned one thing, older John, narrating. Once, I tested a kitchen circuit overloaded with appliances. The breaker held, but the outlet covers were hot to the touch. A week later, smoke curled out of the toaster. The family escaped, but the kitchen was gone. Heat is a liar until it shouts with flames. By the end of the day, the charts blurred in my notebook. Wire gauges, ampacities, breaker sizes swam in my head. Harris looked over our conduit runs, our splices, our labels. Finally, he nodded once. Lesson 1. Wire gauges law. Lesson 2. Breaker protects wire, not load. Lesson 3. Heat waits for arrogance. Code is not suggestion. Code is survival. He snapped the panel door shut. The sound echoed like a gavel. Maria slumped onto a stool, hair damp with sweat. So basically, don't be stupid, as Harris said. Stupidity writes fire. Tomorrow, we leave wires and pipes. Tomorrow, we enter the human battlefield. Construction site communication. And people are more dangerous than electricity. I froze. Communication. Words instead of wires? Maria groaned and muttered. People lie worse than circuits. Harris's eyes glinted. Exactly. Coming up next, Episode 13, Words That Save Lives.